This is Joe narrating a PowerPoint in science. It's in the unit on science practices. It's lesson 4, express and apply scientific information. So in science you will start with basic concepts, build on those, and then apply those concepts to different situations. For example, here's a gas range with the burners on. So you see the light from this range. You also can feel the heat, what's going on. So here's a very simple way of saying what's going on. You have CH4 is a natural gas molecule. It's methane. The 2O2 means there's two molecules of oxygen from the air. They are interacting on your gas range, and you have the arrow showing that they're forming one molecule of carbon dioxide and two molecules of water. So this is a complete combustion of methane. So the chemical reaction type is called combustion, where you have any molecule combining with oxygen, and usually that will give off energy in the form of heat and light. So this is a shorthand way of describing what's going on in your gas. Another way to do it is with these models. In this case you have each molecule represented by spheres or half spheres. For example, methane, the carbon is represented by a black sphere, and the hydrogen atoms are represented by white half spheres. And then you have the oxygen molecules. They're made up of two atoms of oxygen, each one shown by a red partial sphere. And the products on the right are combined in different ways. You have the carbon combined with two oxygens to form CO2, and the other two oxygens combined with two hydrogens to form water. So this is again a physical representation of what's going on in your gas range. An important idea is that matter cannot be created or destroyed. So if you look at the products on the right, carbon dioxide and water, they weigh exactly as much as the reactants on the left, the methane and oxygen. And you can see why this has to be true, because there's the same number of atoms on both sides. They're just different arrangements in molecules. So there's one carbon on each side, four hydrogens on each side, and four oxygens on each side. So the matter, the actual atoms, are rearranged, but there's no change in the number of atoms. Still again, there's another representation of the chemical reaction on your gas range. This is in the form of structures which show the bonding between the atoms. On the far left you see a carbon atom in the middle, and that single line means that there's a single bond to each hydrogen atom. Moving to the right you see the oxygens, the O's, which have what looks like an equal sign, but that represents a double bond between the two oxygen atoms in a molecule of oxygen. So oxygen doesn't exist as atoms in the air you breathe. It exists as molecules, which are two oxygen atoms combined by double bonds to form an oxygen molecule. On the right you see the products. You have a carbon with two double bonds, one each to an oxygen, and then you have the water molecules, where you have an oxygen single bonded to two hydrogen atoms. Again, just a different way of showing the chemical reaction and how the bonds are changed to make different molecules. So you can take that very simple reaction of CH4 and oxygen to extend it to other types of combustion reactions. A common combustion reaction is when you burn octane in your automobile engine. Octane, like the name suggests, has 8 carbons, but it's still the same principle. You're taking that 8 carbon molecule, combining it with oxygen, and forming carbon dioxide, water, and heat. And that's how your car runs. So you see the chemical reaction with the balanced equation on bottom. You see representation of the molecules with the spheres above that. And again, another representation showing the chemical reaction, and in words you would say that octane plus oxygen yields, that's the arrow sign, water plus carbon dioxide plus energy. And the energy is what moves the car. So there are also combustion reactions going on in your body right now if you had breakfast or lunch. So the combustion of glucose is what gives you the energy to do what you need to do every day. So glucose is found in the corn, and here you have a 6-carbon molecule, C6H12O6. It's combining with 6 oxygen atoms, and you are forming 6 water molecules plus 6 carbon dioxide molecules, which you will breathe out, and then you're getting energy from that chemical reaction. So this is what's described as cellular respiration. You're taking in glucose by food, taking in oxygen from the air you breathe. You're forming carbon dioxide, which you breathe out, water, which you breathe out and also urinate out, and you're getting energy to do the things that you need to do from that chemical reaction. That's it.